Hi everybody, welcome to our final lesson here in the reactions unit, looking at limiting reagents, but when given mass instead of moles. So quick recap, this shouldn't be new to you. Our limiting reagent is the reaction or reactant that limits the reaction. Makes sense, limiting reactant that limits. Now what does it actually mean? Well, it means that's the reactant that runs out first, which means no more reactions can occur. You have run out of the ability to do stuff. You've got no more building blocks, no more Legos, no more bread for your sandwich. So what if we were given the mass of the reactants instead of the moles? So for example, a question says like, hey, we've got nitrogen gas, hydrogen gas forming ammonia. Now you've got 47 grams of nitrogen gas. You've got this reacting with 31 grams of hydrogen gas. What's the limiting reagent? How much of that excess reagent is left over? And so this makes a lot more sense than moles, because if you're doing an actual reaction, you're not, putting something on the scale and measuring moles out of there. You're going to be measuring almost everything you do in grams to start with. But we also know that grams aren't super useful for us, right? So I'm going to do this first with the mole table, just because it's easiest to see where everything is going. Moles, molar mass. Let's just do it like this. Molar mass. By now you guys better know that that middle one is molar mass. And actual mass. So let's go back and look at the question. 47 nitrogen, 31 grams of hydrogen. All right. So this is what we're starting with. And as per usual in chemistry, grams are pretty much useless. First thing you're going to got to do, other than the fact that you can weigh them easily on a scale, they don't do us much good for the actual chemistry side of things. So we're going to have to change everything into moles, which means we need molar masses. Now hydrogen is an easy one. I'm gonna eyeball these ones just to make the notes go by a bit quicker. Like I'm gonna be rounding them really fast. You should be using the full molar masses in your calculations, but hydrogen's basically 1. And if I have 2 hydrogens, that means my molar mass is 2. And I'll do the same thing with nitrogen. Nitrogen is like 14.007 or something. Let's just call it 14 for now. And because I've got 2 of them, 14 times 2 is 28 grams per mole. So I need to convert those. 47 divided by 28. I will have 1.678 moles. Let's keep 4 decimals. I should be good with 4 decimals. And 31 divided by 2. Well, I should be able to do that one in my head. Come on, Mr. Burns. That's 15.5 moles. Okay. So now I know how many moles of each reactant I have. And now the question is, which one is my limiting reagent? So now we treat it like a regular limiting reagent question. I've got moles of nitrogen. I've also got moles of hydrogen. And to figure out which one's going to run out first, I've got to turn them both into moles of a product. So let's just do my nitrogen here. And I'll do my hydrogen here, and we'll see which one's smaller. So to convert from one kind to another, divide by whatever this coefficient is, times by whatever that is. So divide by 1 doesn't change anything, but timesing by 2 certainly does. So 1.6786 times it by 2. So my first column is my red one, it's my nitrogen. So if I were to use 1.67 moles of nitrogen, I should make 3 moles of ammonia. And now I'll check my hydrogen, the blue one. I got 15.5 moles. I got to divide it by 3, because there's a 3 here. And then I got to times it by 2. So if I use all my hydrogen up, all 15 moles of hydrogen, I'd end up making 10.33 moles of hydrogen gas. So okay, pretty clear here which one's the limiting reagent, right? We're only able to make 3 if we use the nitrogen. So nitrogen's our limiting reagent. So what we do now is, the nitrogen's the important one. I'm going to rewrite the mole table here, actually. It'll probably be easier to see. Okay, so if nitrogen's my important one, I'm going to keep my moles there for nitrogen. I don't care about this one, because that 15.5 moles it doesn't really mean anything anymore. I'm not going to use it all. I'm going to use some amount of it, but I don't know how much. So that number itself isn't really important. What I got to find out is how much I'm actually going to use up. I know I'm using all of this. It's my limiting reactant. That's what I'm going to run out of. I just got to figure out how much hydrogen I use. And of course, I don't care at all about the products at this point. I'm only worried about how much hydrogen I use. So all I have to do is convert moles of this, moles of nitrogen, into moles of hydrogen. So I divide by 1 and I times by 3. 1.6786 times by 3. Turns out I will be using up 5.0358 moles of hydrogen. That's what I'm using up. So I can look up at my original mole table and know I was given 15.5 moles. And I know I'm going to use up 5.04 moles divided by 5.04, which means I have 10.46 moles left. And if you want to figure out your mass, we can use the molar mass again, right? Changing mass and moles into mass and mass into moles is always molar mass. So in this time, I'm going out of moles into mass, and the molar mass of hydrogen is 2 grams per mole. So you just times it by 2. So you got 20.92 grams. I just did that one in my head, but I think I'm good. Of H2 gas. So that would be a full molar mass mole table version of doing this. Now, if this works for you, fantastic. You're kind of good to go. If you prefer the math way of doing it, well, let's write down the same equation. I've got 2 of those with 3 of those, and I'm good. Okay. I'm also going to write down, as per usual, what they tell me in the question. 47 grams nitrogen. And I know 31 grams of hydrogen. Okay. Now, of course, we know grams aren't very useful, so we're going to have to change them. You need some method to keep yourself organized. I sometimes just like to label mine. Like, I'm going to do my hydrogen up here, or nitrogen up here, sorry, my hydrogen down here. That way I don't have to keep writing nitrogen after every chemical. 47 grams, I need to get out of grams and into moles. And I know that 1 mole is, look up the molar mass, 28 grams. Which gives me 1.6786 moles of nitrogen gas. All right, hydrogen, 31 grams. 1 mole is 2 grams. Again, roughly, you want to use the full ones when you actually do it, but that gives me 31 divided by 2, 15.5 moles of H2. Now, if I want to convert these moles into something else, let's say I want to convert them into moles of ammonia. I'm going to show you the unit analysis way. You can do the have over need thing here if you want, but the unit analysis might almost make more sense to you. I'm changing out of moles of nitrogen gas, changing in to moles of ammonia. And in this one, I'm changing out of moles of hydrogen gas and into moles of ammonia. And I want to see which has more or less moles of ammonia. Okay, so then what goes here? What is the relationship between the number of moles? That's the big question. And the thing that relates your moles, well, that's just these coefficients up here. That's what the balanced equation tells you. It tells you how the moles are related. So N2 is right here. It's a 1. And ammonia is right there. So every 1 mole of nitrogen should make 2 moles of ammonia. And if you look at your unit analysis, my moles of N2 will cross out. I'll be left with moles of ammonia. When I times it by 2, I find out that 3.357, so the answer to this is 3.357 moles of ammonia. And that's on my nitrogen line. I can do the same for hydrogen. 3 moles of hydrogen, every 3 moles of hydrogen gives me 2 moles of ammonia. So, all right, fair enough. 15.5 times 2 divided by 3 gave me 10.33 moles of NH3. So I look at these 2 numbers and I see which one's smaller, and I have my limiting reactant. So once again, limiting reactant is nitrogen. I'm going to have to add a slide here. So you say, okay, if nitrogen is limiting. That's the one that's important. So I'm going to look at how many moles do I actually have of nitrogen. Well, I calculated it right there. 3.35. Oh, no, sorry. That's how many moles of ammonia I have. My moles of nitrogen's there. That's why it's good to label things. You can actually read them and see what you're talking about. 1.6786. If I had 1.6786 moles of nitrogen, again, you can use the have over want formula if you want to convert it, or you can use your unit analysis. How do I change moles of nitrogen into moles of, what am I trying to find now? Well, I want to find how much hydrogen I've used up. So I'm just going to title this, how much hydrogen used. Well, I know that I'm using this much nitrogen. I'm using it all. So how much hydrogen did I use? What's the relationship between moles of nitrogen and moles of hydrogen? Well, 1 mole of nitrogen should give me 3 moles of hydrogen. 1 mole of nitrogen should give me 3 moles of hydrogen. So I take that 1.6786, I just times it by 3. So that's how many hydrogen moles we've used. That's very important, right? That's used. That's not left. That's used up in the reaction. So then you can say, okay, I started with 15.5 moles of hydrogen. That's what they told me originally. So I had 15.5 moles of hydrogen. I used 5.03 moles of hydrogen, which leaves me with, what was my answer before? Just so I don't have to do the math again. 10.46 moles of hydrogen. And if you needed to change it into grams, you've got moles. So it's just a molar mass calculation. 2 grams is a mole. So you get 20.92 grams of hydrogen. So that's the basic steps for doing one of these. I'm going to do one more for you guys here. So if you want, if you're feeling confident, you can pause this and see how far you can get. See if you can beat me. Otherwise, we'll be able to follow along. I'm going to do this one. I'm going to do this one just using the mole table, maybe. Nah, I should do them both. Why not? Show them both. So here's the deal. You're given 25.61 grams of both reactants. Which one limits the reaction and how much excess? So step 1, write and balance your equation. I mean, this one was already balanced, which was nice, but if it isn't, very important step. If you're doing a mole table, you'd set it up. If you're not doing a mole table, you're just going to start working into finding moles right away, because we know that molar mass is, or that mass is no good. And they're both 25.61. Very nice. So the molar mass of CH4, I know carbon's about 12 plus 4. That'll be about 16 grams per mole. And 2 oxygens, well, each of them is about 16. So let's call it 32 grams per mole. So 25.61 divided by 16. So I've got 1.6 moles of methane. And I've got, divided by 32, 0.8 moles of oxygen gas. Okay. Now I can pick which of these, right, for limiting reagent, I don't have to do them both. I can pick which one I want. Let's do methane in blue. Let's do oxygen in red. And I don't care. Let's do carbon dioxide just because it's got a 1 to multiply by, right? That makes things easier for me. So 1.6 divided by 1 times 1. Well, that's not so hard. It's 1.6. And then for red, I take 0.8 divided by 2, which is 0.4. I times 1, and I'm at 0.4. So which one is limiting? My red one's going to be limiting, my oxygens. Oxygen is definitely my limiting reactant. So that tells me, all right, if oxygen is my... Normally I'd set up another mole table to show everything out, but I'm a little bit... Actually, I could show them another one. I'll just do this. Yoink. Now I have more room. I mean, if it was my own personal work and I was in a hurry, I would just erase this column here and start over, because methane doesn't matter anymore. It's not the limiting reactant. If you're going to show your work, you definitely want to be showing everything. So drawing another mole table will probably be the easiest way to do it. Well, I don't even need the products. I'm only concerned with reactants at this point, right? So I know I have 1.6 moles here, and the question is, how many moles does that make? So I do 1.6 divided by 1 times 2. Wait a second. Yeah, that's right. Oh, something weird happened here. Oh, times 1.6, yeah. 0.8 divided by 2 times 1. Right. Why am I confused? 1.6 divided by 1 gives me 3.2. But I started with, how can I use 3.2 if I have 0.8 moles only? Something's weird. This tells me, okay, if I'm using up more moles than I have, that's telling me that oxygen is my limiting reagent. Oh, because oxygen is my limiting reagent. So here's a common problem you might run into. I put the wrong one in. And you'll notice it right away. I am using up 3.2 moles and was only given 0.8 moles. I can't use up more moles than I have. I have the wrong limiting reagent. If you're trying to use up more moles than you have, you put the wrong number in. There we go. Yeah, the red one is my limiting reagent. That one, the oxygen, not the methane. Why was I putting methane in there? Ugh, silly. So, okay. 0.8 is what I'm going to use up. That's my limiting reactant. 0.8 divided by 2 gives you 0.4 times 1 stays at 0.4. So 0.4 is how many moles of methane I'm using. And I started with 1.6. So I should have 1.2 moles left. And of course, you could times that by molar mass if you wanted. Now, if I want to do this math-wise, same thing. CH4 plus O2. I'm always going to start with the balanced equation. It's just really important for you to have that written down somewhere so you can see what's going on. 2 CO2s. What? Gives me CO2 plus 2 H2Os. All right. And I know that they're both 25.61 grams. I just put it underneath Canamol table style just because it helps you see what goes where. And again, I'm going to do two rows, I guess. One for CH4, one for O2. Step 1, grams are useless. Change grams into moles. Change grams into moles. So for carbon, again, is 12 plus 4 is 16. Oxygen times 2 gives me 32. I do those divides and I get 1.6 moles of CH4. And this gives me 0.8, was it? Yeah, 0.8 moles of O2. All right. Now I need to change from moles into moles. You know what? Let's do the water now. I just want to show you guys that it doesn't matter which way you do it, which product you choose, you still get the same limiting reactant. So I need to change out of moles of CH4 into moles of H2O. This one's changing out of moles of O2 and into moles of H2O. So moles of CH4, well, it's a 1. Moles of H2O is a 2. Moles of O2 is a 2. Moles of H2O is a 2. O2 is right here. Okay, H2O is right there. All right. 0.8 times 2 divided by 2 stays at 0.8. So that's for oxygen. 1.6 times 2 gives me 3.2. So that's for my methane. Which one's smaller? It's still O2. Doesn't matter which one I use, you still get the same limiting reagent. You'll get different numbers, but it's the same limiting reactant. All right. So if oxygen is my limiting reactant, then I need to know, when I use all my oxygen up, how much methane is used. So I go back and I check, all right, I used up all of my oxygen. How much oxygen did I have again? Right there. I don't want it to be in grams. You could change it back to grams if you want, but we already did that calculation once. So I'm going to keep that one. And I want to say, okay, I don't want moles of O2 anymore. I want to see how much CH4 I need to be in moles of CH4. What's my relationship there? 1 CH4 should use up 2 oxygens. 1 CH4 should use up 2 oxygens. There we go. 0.8 times 1 divided by 2. I should use up 0.4 moles of methane. And I can look back to my old calculations and see that, well, they gave me 1.6 to start. Mole to start. And I used 0.4. So I'm still left with 1.2 moles of CH4. So hopefully that is fairly clear. You're going to have a lot of chance to practice. And again, whether you like doing it that way with the unit analysis stuff and getting rid of it, whether you like the mole table, if you want to stick with the what I have over what I need formula, these are all good ways to track your information. So that's about it for me today, and I will catch you guys later.